Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel. Today we're going to be working on question 3 and we're on episode 3 of the solving trigonometric functions using quotient rule series. And as you can see in this question, we have f of x equals sin x over tangent x. So therefore, we're supposed to find the derivative of sin x divided by tan x. From the thumbnail, from the title, from the description, if you're one of those people who reads the description before watching the video, as well as the first few things I've said in the video, we're going to apply the quotient rule. And the reason is because we have a function that comprises of numerator subfunction and a denominator subfunction, hence a fraction. The function that we have is a fraction. So one subfunction divided by another subfunction. In order for us to differentiate when questions appear this way, we're going to apply something called the quotient rule. And the quotient rule is basically the derivative of the first or numerator subfunction multiplied by the denominator subfunction minus the derivative of the denominator subfunction multiplied by the numerator subfunction. All of that information divided by the denominator, hence g of x all squared. So that's basically the general form that the quotient rule will take. Now that we already identified that we're going to apply the quotient rule to solve our question, we can go ahead to apply the quotient rule to this specific question. So we have d dx of sin x over tangent x to be the derivative of sin x, which is f of x. So basically, I'm going to write it in black up top. F of x, numerator subfunction is sin x. So look at the top right hand corner of the screen. And g of x, the denominator subfunction is tan x. So that's it. So you have the derivative of sin x multiplied by g of x, which is the denominator. So that's tan x, minus the derivative of tangent x, which is g of x, multiplied by f of x, which is sin x. All of that information divided by tan x squared. So tan x, all in bracket, squared. So now that we have that information, we're now going to start solving. So you have the derivative of sin x as the first thing you need to do. But what is the derivative of sin x? Now, if this is the first time that you're watching my YouTube channel or watching a YouTube video, then you probably do not know this. I always have a page dedicated to Trig Notes. So anytime I'm doing any video that relates to trigonometric functions, just like if I'm making a video on limits, I have limit laws and things like that. So in this particular video, we have a page that is dedicated to the different formulas for trigonometric function that we're going to need throughout the series, as well as a note that you can have a personal copy of. So like you can pause this video, write it down just to help you as you solve and as you work through trigonometric related topics. So on the left hand side, everything in blue is actually called Trig Expression, and just involve how one trigonometric function relates to another trigonometric function. So how sin x relates to cosecant x, and they are related in terms of reciprocality. The same way cosine x relates to secant x in terms of reciprocality, hence cosine x equals 1 over secant x and secant x equals 1 over cosine x. The same way tan x relates to sine and cosine in this way, right? And cotangent x relates to cosine and sine in this way, as you can see. So that's it. And then on the right hand side, we have everything that has squared, right? On the right hand side of the Trig Notes up top is called Trig Identities, as I'm currently writing on the screen. And which just involves trigs that have squares and how they relate to one another. So you have sine square x plus cosine square x equals 1. Cotangent square x plus 1 equals cosecant x, and as you can see, tan square x plus 1 equals secant square x. So then everything written that is at the bottom, that is written in red, is derivatives of trigonometric functions. What is the derivative of sin x? We have that to be cosine x. Derivative of tan x, we have that to be secant square x. And so basically everything here is just good for us to use for proper practice. So everything in the red marker currently are called trig derivatives. What was our question again? We're supposed to find the derivative of sin x. So let's go down. What did we see the derivative of sin x to be when we look at the stuff written in red marker? We see that to be cosine x. So we're going to substitute and put a cosine x here. Then we have multiplied, hence the dot, by tan x, right? Minus, what is the derivative of tan x? Let's go back. Well, the derivative of tan x, we'd have that to be secant squared x. Interesting. So we're going to put that here. Secant squared of x, right? And multiplied by sin x. So we have that information, and then we have tan x all squared. All squared. Everything in brackets squared. So now this answer is like correct, perfectly alright. But because we're dealing with trigonometric functions, just like every other thing in maths, we like to simplify our work. Even though we've applied the quotient rule and we've gotten our answer to be this, there's a way for us to break down the information further, so we're not just having a whole bunch of trigonometric, we're not having an answer that is very complicated with a whole bunch of trigonometric functions. So just like you would, instead of having 600 divided by like 10,000, you rather have it to be 6%, right? That's just basic math simplification. So I'm going to rewrite what we have on the previous page. I'm going to put it on the new page, and then we're going to start to simplify. So what we have was cosine x multiplied by tan x minus secant squared x multiplied by sin x, all of that information divided by tan. Now, you had, as I wrote tan x, right, and I put everything in squared, I could also call it tan squared of x. So tan x, everything squared, is the same thing as tan squared of x. Nothing that is different. It's just a different way of representing it. So that's the little switch that happened. So you have this here. So how do we proceed? Well, one thing we can do is this. Cosine x, sin x, we can try to, we're going to simplify, right? So we have cosine x, tan x, minus, what does secant x represent? If you look at secant x here, we see that secant x is the same thing as 1 over cosine x. But then here we have secant squared x. So instead of having 1 over cosine x, is this just like secant x is the same thing as secant x, just like secant squared x is the same thing as secant x multiplied by secant x for us to get secant squared x. That's the same way 1 over cosine multiplied by 1 over cosine is going to give us 1 over cosine squared x. So when we have secant x to be 1 over cosine, we have secant squared x to be 1 over cosine squared of x, right? All of that multiplied by sin x. So all of that information divided by tan squared of x. So we can now do it this way now. We have 1 over cosine squared x multiplied by sin x. So one thing you need to know is we can have this here, sin x, tan x, this way, right? We can also have this to be sin x, right, over cosine of x. And we can have multiplied by just 1 over cosine x, because we split this cosine x, we split this cosine squared x into 2, so we split it that way in order to make our work easier to simplify. So you have tan squared x. Now we have sine over cosine. We're going to continue on the next page, sine over cosine. So we have cosine x, tan x, minus sin x over cosine x multiplied by 1 over cosine, right, x. all of that information divided by tan squared of x. Well, what you have to do here is basically, what does sine and cosine represent? If you look at your trig notes, sine and cosine, when we look at trig expression, you see that sine over cosine represent tan x. So tan x right here equals sine over cosine right here. So we can just put this here and we're going to change it. So cosine x, tan x, right, minus tan x over cosine of x, because we multiply these two together. So over tan squared x. So we end up with this here. So we're going to bring out a tan x here, and then cosine x minus 1 over cosine of x, and all of that divided by tan squared of x. Okay, so now we can cancel out. So cancel this out, and we have this to be cosine x. What did we say? What did we basically say this is? We have minus, so basically this over 1 over cosine x, right? All of that information divided by tan x. And yeah, that's basically our work so far. But guess what? We're not done, because we're just not done. So remember 1 over cosine. What does 1 over cosine represent when we look at the trig notes? Oh yeah, 1 over cosine represents secant x, which is what we just have here. When you look at the trig expression part of the notes, so we have that to be cosine x minus secant x, right? Because 1 over cosine equals secant divided by tan x. And yeah, that is basically the answer so far. But again, we can still break it down since we're dealing with trig. So cosine divided by tan is the same thing as sine. So I'm going to switch the color now to blue, actually to red, because it pops out more. So you have cosine x, right? If you're going to do it, if you're going to split the fraction, you have cosine x divided by tan x, right? Minus secant x divided by tan x. So this is equals to cosine x over sine over cosine, sine x over cosine x, minus 1 over cosine of x divided by sine over cosine. So you're going to divide this, basically this one here and this one here. You divide the cosines and take them out, and then you have cosine x divided by sine x minus 1 over sine. So we're going to put that on the next page. So we have cosine x divided by sine x over cosine x minus 1 over sine of x. So that is now equal to cosine of x divided by sine x over cosine of x, right? Minus 1 over sine x. You guys, are you bored already? Nope. So this divided sign is just basic math. So we have all of that equals to same thing as cosine of x. Whenever you're doing a division, just like you have 5 divided by 1 over 2 is the same thing as 5 multiplied by 2 over 1, right? So that's what we're going to do here. So we're going to flip cosine and sine in this question. So we have multiplied by cosine x over sine x minus 1 over sine of x. And yeah, what do we do here? Well, we can do math by just bringing out 1 over sine. So we're going to bring out 1 over sine x here. And then you have cosine x multiplied by cosine x. So you have cosine squared x. And when you bring out 1 over sine here, you get minus 1. So this is basically the answer. But then we're not done, because we can try to see if we can do more to this. When we look at our trig notes, let's see if we can simplify further. From our trig notes, we see that when we look at trig identities, since we're dealing with how one trig function that has squared relates to another trig function that has squared, we see here sine square x equals cosine square we see that sine squared x plus cosine squared x equals 1, right? Okay, let me put it here for us to remember. Let me use red, let's put up more. So remember, sine squared x plus cosine squared x equals 1. So therefore, if you want to have cosine squared x minus 1, what is that going to equal? So cosine squared x minus 1, when we take 1 over, when we take negative, we have to take negative sine x, because we want cosine squared x minus 1 to be the subject of formula. When we take sine squared x over, we have negative sine squared x. So now we end up with 1 over sine x, right, multiplied by negative sine squared of x. And yeah, so what we do now is cancel this out, cancel this out. So when we cancel one of the sine x from the sine squared x, we have a sine, so our answer becomes a negative because of the negative here, sine x. So now this is the most simplified way we can get our work to be. Now one thing I want to show you guys is this. You see the importance of breaking things down in mathematics. If we had just applied the quotient rule, we could have just gotten this answer, and this answer is actually okay. So this answer is good. When we broke it down further, and we got this, this answer, it was good, and we got this answer, it was also good, and we also got like this answer, it was good. But the best for math is for us to make sure to simplify it to the lowest possible information. So we have negative sign, which is the best. Imagine if you had to memorize this, and you had to say, if you had to memorize what an answer would be, would you rather memorize negative sine x, or would you rather do this cosine x multiplied by tan x minus secant square x multiplied by sine x divided by tan square x? That's a lot of work to do, and we don't have time. So that's it. That's basically the answer. So now I want to show you guys a shortcut method to doing this, so you don't spend forever trying to do math. So the shortcut method is this. We had sine x, right, over tan x, which was our question, and we were asked to find the derivative of this. Well, the shortcut method, as if you guys have watched my solving trigonometric function using product rule, the shortcut method, if you have watched my solving trigonometric function using product rule, you would see that I always simplify this function before we derive it. So that's what the shortcut method entails. You simplify the function, right? You simplify the function, and then when you simplify the function, you can then differentiate the simplified version of the function. So you have sine x divided by tan x. Now we have sine x divided by tan x. Instead of differentiating it, we're going to see if there's a way for us to break it down. Sine x over tan x is the same thing as sine x divided by sine x over cosine x, because tan x is the same thing as sine over cosine. So when we remember how we're supposed to do math, we can basically cancel this top out, so we end up with 1 divided by, since this one is cancelled out, we end up with 1 over cosine of x. And then when we go ahead, what is 1 divided by 1 over cosine x? That's the same thing as 1 multiplied by cosine x divided by 1. So our answer is cosine x. So now that we already have the simplified version of the function, we can go ahead and solve for the derivative of this and the derivative of this of cosine x, which is our simplified version of the function. Let's go to our beautiful trig notes. What does the trig note say? The derivative of cosine x is the same thing as negative sine x. So therefore, our answer is now going to be negative sine x. And then now you see our shortcut method. The shortcut method is really good to use whenever you're doing you have to do like a multiple choice question and you do not have time to be solving and to be looking and to be searching and all the other stuff that could come with math, rather than having all this just because you're applying quotient rule, like all of this information that we've had so far. If you just use the shortcut method, you can get the answer to be negative sine x. When you compare the work negative sine x that we got here in this shortcut method to our actual final answer, it's also negative sine x. So therefore, the shortcut method works and proves that the quotient rule is correct. So I hope you guys are doing fine, and yeah, this is basically it. And yeah, I wish you guys all the best. If you have any questions, please look at the description box. If you maybe the question probably would have been answered, and if it has not been answered, please put the question down in the comment section and I'll get to it. And if there's a question that somebody else asks that you'd like to ask, just like that question so it'll be easier for me to see it. Make sure you guys take good care of yourself, and I'll see you on the next video. Assalamu alaikum wa rahmatullahi wa barakatuh.